Hey y'all, welcome back to another video. Today's first question is, how many pairs of primes are there such that the sum of the pair is 40? So we're looking for primes, two primes in a pair, and the sum of the pair has to be 40. So like adding together, not like the digits like before. So 1 is not a prime or composite, so we can just quickly get out of that. 2 is a prime. But if you have to add it to an even number to create 40, 38. Since 40 is even, you either add it with 2 odd numbers or 2 even numbers. And 2 is the only even prime number, so we can just get rid of all the even numbers, mostly because they're all divisible by 2, and everything that correspond with. But 3, you have to add 37 to it. Right, like this. 37. That's 40. 4, it's even. 5 has to add 35. 35 is not prime. 6, even. 7, you add 33, but 33 is not prime either, so we can get rid of 7. 8 is literally not even prime. 9 is also not prime. 10 is also not prime. 11, you would have to add 29. 29 is prime, correctly. 13 to 27. 27 is not prime. 15 is not prime. 16 is not prime. 17 is. 17 would correspond with 23. 19, then you would add 21, but 21 is not prime. And then you can see that the next couple numbers is just going to be this thing folding over again, because then it would be 23 and 17, 29, 11, and then 37, 3, so on, so on. Now we just need to look at how many we have. We have 3 of them, so there are 3 pairs of primes such that the sum of the pair is 40. Mostly we're all solving. Question number 2. The product of all prime numbers between 1 and 80 is divided by 10. What is the remainder? So this problem, you kind of have to list out the first couple prime numbers. If you've already memorized it, there's no need for that. But you gotta go 2 times 3 times 5. And by the time you get to this point, you can see that you have a 2 and you have a 5 and it's asking for 10. So if you multiply the 2 and 5, 2 times 5, 2 times 5 equals 10, right? So anything else, so now that we've gotten rid of the 2 and 5 to make 10, we can multiply. Everything else is just that many 10s. And if you're going to divide it by 10, it's just going to be that number remaining. And if you've multiplied 10 in, that means that it's just going to be blah, 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 0. And to divide by 10, you take away 1 decimal point from the number, and now here we have a 0, so you can just get rid of that 0, and it can fully divide, leaving no remainder, so the remainder is 0. Hope that makes sense. Moving on to problem number 3, the product of all prime numbers between 1 and 80 is divided by 4. What is the remainder? So this problem is a little bit different from the problem above. If you try, you know that 2 is the only even prime number, so it's like 2 times 3 times 5 times 7, blah, 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 times. You know that 2 is the only even prime number. And if you try to whittle down 4 with 2, you know that it remains with 2, so if we get rid of that and that becomes 2. All the other numbers in this sequence are not even. So you can't divide any of those by 2. Meaning that the remainder is not going to be 0, unlike the problem above. However, there's still a way to do this without doing the entire problem and then dividing by 4. First, you know that any remainder of 4 has to be between 1 and 3, because any higher than that, you could just put another 4 in, and then it wouldn't be the same anymore. So we have 0, 1, 2, 3. And we know it's not 0 because we just checked it's not going to fully divide in. And since you know that this number, since we have 2 and you multiply into that, it's always going to be even, we can just get rid of 1 and 3 because it's not going to leave an odd remainder because 2 is there. Guardian angel. So our only remaining number, because 0 is the only other even number in this collection of numbers, and 0's already been eliminated, so the only even number left is 2, which is why the remainder would be 2. So yeah, that's the end of this video. I hope you guys enjoyed and I hope you guys learned something new. And I'll see you guys on the next one. Bye!